I will be discussing the piecewise functions. The first example is going to evaluate, and then later on, I'm going to determine intervals, how to find the domain and range, how to write the piecewise function when you're given a graph, and also how to graph when you're given a piecewise functions. So as I mentioned in the first example, we're going to evaluate the following. We're going to evaluate the following using f of x is equal to, and then I have rules shown here with criteria. My criteria, you'll notice, has x's in them. So that's what I'm going to use to evaluate. That's how I determine which one of those rules goes with which. F of x represents my y, but I am going to replace the x with the number that's shown in the problem. So for the first condition, what I typically like to do is I like to look at my inequality and visualize it as an arrow, because I'm just going to have a number line to the side. You don't have to do this. This is just for those people who need to see what's going on. I'm going to use that number, -3. And I know I have a number line going to the left because that's what my inequality looks like. I also have an equal sign under my inequality, which tells me that my -3 is included. So I'm going to have a closed circle at -3. My x can fall anywhere to the left of -3. So what numbers would that be? That could be -4, -5, -6, so on and so forth. It's counting outward. If you go the other way, -2, -1, it's getting bigger. So make sure you understand the difference. The next condition, the x is greater than 5. It doesn't have an equal this time. So I'm going to have an open circle, and this time my arrow is going to the right. So going to the right, I'm going to have an open circle starting at 5. Any x values that come after that, any numbers that come after it can be an x value. So 6, 7, 8, 9, so on and so forth. And then this last condition, I have two endpoints, I'll call them, -3 and 0. So the x's are sandwiched in between those. This particular inequality does not have an equal sign. So it is going to be an open circle. My x is anywhere in between those two numbers. And at 0, there is an equal sign with my inequality. So I'm going to actually include the 0. So I can have -1, I can have -2. So any of those numbers, because they fall within -3 and 0 for my x values. So now when I go over to evaluate, what I want to look for is which one of these conditions actually has a -2 in it. And if I'm looking at it, I see -2 falls into this rule. So that's the actual function that I'm going to evaluate. I'm going to take my 7 minus 2, and instead of using an x, I'm going to replace it with -2. So -2, and anytime I want to substitute, I personally like to use parentheses. When I simplify this, this is 7 plus 4, because -2 times -2 is +4, which results in a +11. Going to the next one, part B, if I'm looking for the condition or the criteria that has the 8 in it, that's the second one. So x can be any number that's bigger than 5, greater than 5. That's what that means. So I'm going to take that rule, which is the absolute value of x minus 5, and I'm going to replace that x with 8. So 8 minus 5. And the absolute value of 8 minus 5 is 3. And if I keep simplifying, it is simply a +3. And then part C, I'm going to look at -3. Well, if I'm looking here, I see a -3 here and a -3 in the third rule. How do I know which one to choose? You want to choose the one that has the equal sign because it's actually included. That's why I personally like to look at the visual representation so I can quickly see it. And now I just want to take that rule, which is x squared plus 3. But instead of x, I want to replace it with -3. And again, make sure you put it in parentheses. Otherwise, you will get the wrong answer in your calculator. -3 times -3, that's what -3 squared means. is positive 9. 9 plus 3 is positive 12. So that's my answers when I'm evaluating. For example 2, I am asked to graph the piecewise functions that are shown below. So I color coded it so that it's easier to see when I start to graph. What I like to do is I like to determine first what type of what type of graph will each one of these functions look like. Well, I see for my first rule that that's a linear graph, and it has a negative slope. So I know it's going to go downward. So that's going to look something like this. And you'll notice I wrote it down by a table. What I do for each one of my rules is I create a table. I have X and I have Y, and then in between, I would actually have whatever the rule is so that I can substitute it. What numbers am I using? I'm using whatever the condition says. So I'm starting with the number that's actually shown. So 4. And then I notice that it is an open circle because it's greater than, but it's not equal to. So I'm also going to put an open circle there. And what I want to do is I want to take this -3, replace the X with 4, and then add 2. Simplify this. -3 times 4 is -12. -12 plus 2 is -10, which is going to leave me with the coordinates 4, -10. And then what I'm doing is following my directions. So anything that's to the right of 4, I can use. I'll just use 5, which is the next number. -3 times 5 plus 2 is -3 times 5 is -15, plus 2 is -13. So my ordered pair is 5, -13. I'm going to take those 2 points and I'm going to plot them on my actual graph. I didn't mean to move that, but it's okay. All right, so now I go over to +4 and -10, and I notice I have an open circle, and then 5 and -13, which is just a normal point. You don't have to try to do an open circle or a closed circle. Now, I remember that the graph should be a downward line because of the slope. The slope is negative, but it does not continue on to the left. It has to go based off of the rule. And excuse my crookedness. Hold on. Let's try to do better. Here we go. Something like that. And again, the reason it looks like that instead of going straight down like this is because I had to follow my condition. My condition said that my X's can only be 4 or greater. That's why it looks like that. In addition to me not knowing how to draw correctly. And then for my second rule, I'm going to take my 2 endpoints, and then I'm going, whatever the inequality is next to them, I'm going to remind myself that's either it's going to be a closed circle or an open circle. So for -3, I see there's an equal, less than or equal sign, equal to. So there's going to be a closed circle. And then I'm going to use 3, which is an open circle because it's just less than. And what I like to do is just use a number in between, which typically for me, I'll use 0. And the reason I'm doing this is because this time, this is not a linear graph. This is a parabola because it's x squared. And it is actually facing upward because there is a positive leading coefficient. So I know that both of my arrows are going to go up because it's an even degree. And like I said, the leading coefficient is positive. What I want to do is just substitute for x into the rule. So -3 squared is 9. 9 minus 2 is 7. -3 and 7 is my coordinate for that one. 0 squared minus 2 is just going to leave me with -2. So 0, -2. And I also have 3 squared minus 2, which is the same as above. 9 minus 2, 7. 3, 7, because a quadratic parabola is going to be symmetric. So once I plot those points, I have okay, that's a closed circle. At -3 and 7, I have a closed circle. And then at 3 and 7, I have an open circle. My additional point that I used was 0 and -2. That just happens to be my vertex. So I'm going to attempt to draw this parabola. It's not going to be perfect, but it's okay. So that's my parabola. And then I want to go to my third rule. My third rule says that y is equal to 5. So no matter what I put in for x, y is going to be 5. So for my table purposes, I can just go ahead and write 5. What that means is on my y-axis at 5, I'm just going to draw a horizontal line. So my graph would look like this, except we're doing piecewise. So it may not be the entire graph. It's just that's what the original graph should look like. But once I start putting my conditions in, it may be partial or a piece of that graph. So I'm going to use -4 because that's what's shown. And any number that is less than -4. So that means going to the left. So I'm just going to use -5. But it really doesn't matter because either way, the output is still going to be 5 based off of what the rule said. So I noticed that there's an equal sign in my inequality. So I'm going to have a closed circle where it is -4. And this is -4 and 5 and -5 and 5 if you're keeping up with your coordinates. So go over to -4, go up 5, and put a closed circle. And anywhere to the left, it should be a straight line, I can have x's that will fall in my graph. So this is what it will look like when you're manually graphing it. And now let's go back to our rules. If I'm using a calculator, I would go to y equals. And as you can see, I've placed the piecewise rules in there, the functions, as well as the conditions. So for the first one, I did -3x plus 2 divided by parentheses. Then I went to second math, and that allows me to choose my inequalities. And I chose the greater than symbol, 4, and then I ended with another parenthesis. So I'm going to show you the rules so that you'll know how to actually use the calculator, especially if it has and in it. So at this point, you can just pause it, screenshot, whatever you need to do. But these are the steps so that you can enter it under the y equals. And then what will happen is, let's go back to it. We can hit graph, and it looks like what I just manually did. If you don't see all of your graph, then again, you would have to go, you would have to go to window, just window, and you would have to adjust it. X min means you want to see more to the left. X max means you want to see more to the right. Then if you go to Y min, that means you want to see more to the, that's down. Y max, more that's up. So anytime you see min, you have to have a negative sign in front of it. You can color code as well, which is what I did with my graphs. So when I graphed it manually, I had orange and green at the top, orange and green at the top, and then pink at the bottom. All right, so now for example 3, I am asked to write the piecewise function for part A, and then for part B, determine the interval of increase, decrease, and the constant. So let's start with the piecewise function. So when I'm writing this, what I want to do for me, I'm just going to go from left to right. I'm going to start with this one. I know that this means that it's crossing the y-axis somewhere. And when we're starting off a piecewise graph, what we're looking for is the y part. So f of x is equal to, and I see 3 graphs, so I'm just going to make this big enough for 3. And I said the first one is y is equal to simply 7. So now we just have to determine, well, what's the condition for that? And normally I do the conditions first, but we'll just go, yeah. What's my condition? My condition would include my domain. So my domain is all of my x values that are included in the graph. Or even if it's not included, so like here, I'm going from -8 to -3. So I know that's my limit. So I'm going to go from -8, and then I'm going to go over to hold on here. Let me just scoot this over. -8. I know I'm going to have an x in between, and then I'm going to go to -3. So when I'm doing this, looking at this graph, I see that both circles are open. So that tells me that my inequality is not going to have an equal sign under it. It's just simply going to be less than, because x can fall in between -8 and -3. So my next one, I have to visualize this as a parabola. Well, that's what it looks like, a partial parabola. Well, my parabola's parent function is normally here. What happened? I moved over 1. So I'm looking at it from a point of view of transformation. So I moved to the right 1. And if I'm talking about moving to the right, I'm going to have something in parentheses raised to the second power. Why is it negative and not positive? Because what you're looking at is, what does x have to be? X would have to be 1 to make that equal 0. And where is 1 on a graph? To the right or to the left? It's to the right, okay? So now my condition is, what is my domain for those two? I mean, for this graph. So it's starting at -1 and it ends at 2. So for the -1 side, it's a closed circle. So that means that that one is going to have an equal sign under it. So everything is going to be less than or equal when it's sandwiched in between. And then for 2, it is not included. So it's simply less than. Now for our third graph, we know this is linear and we know that it's a negative slope because it's going downward. It's also including this point. My domain is going to be from 3, and it just keeps going on forever because of this arrow. So that's going to be 3 to positive infinity. So if I'm writing this backwards, well, not backwards, but if I'm writing a condition first, that means that x can be anything greater than or equal to 3. So then how do I find the rest of it? So what I want to do is, first, I want to look for the slope. The slope is going to start from that point. Well, that's the way I do it. 1, 2, 3. That's not a nice one. 3. And then down 1, 2. Your slope is rise over run. So rise means going up or down. So that means it's 2. And run means it's going left or right. And it's 3. And I see that it is going downward. So it is a negative. So it's going to be, since it went down, I guess it would be easier or better to just put -2 here so nobody will forget the negative. So that's my slope. Now I want to see, well, what would it have been if I'm trying to cross over my y-axis, because I want to find if I put it in slope-intercept form, I want to know my y-intercept, which is identified by b if I'm using y equals mx plus b, right? So I can do the same thing. I can use my slope and I can go up 2 this time, 1, 2, and then over to the left 3, 1, 2, 3, as long as I account for that negative sign. So where did I end up? I ended up at -5. So we're going to say that our y-intercept is -5. Let's try another way. Let's take the actual point 3 and -7. So 3, -7. This represents x, this represents y. If I'm putting it in the slope-intercept form, I am going to take the y and I'm going to substitute it for y. So that's going to be -7. My slope, we just said, and this is slope m. My slope, we said, was -2 over 3. And then my x is simply 3. We're trying to find b. So if you know anything about multiplying, you can either multiply this out and say -2 times 3 is -6. -6 divided by 3 is -2. Or you can just cross those two out since they're exactly the same and just bring down what's left over. So then you would have -7 is equal to -2 plus b. To find b, you would just take the 2 and add it on both sides, and it is -5. So that is your y-intercept. Why is that important? Because that helps me to determine what my rule is. My rule is going to be -2/3 x minus 5. And if I wanted to know if all of this is true, all I have to do is just follow my condition. If I took 3 and I placed it here, which I just did a few minutes ago, right here, it's going to give me a -5. So if I went to +3, if I put a 3 here, sorry, let's do this again, -2/3, and I put a 3 here, -5, 3's go away, -2 plus -5 is -7. Well, what did I just do? For x, I put in a 3, and for y, my output, or f of x, was -7. Well, these are coordinates, so let's see if that's true. If I go to 3 and down to -7, yes, that's a coordinate. So I understand that this is correct. And I would do that for each one of those. That's how you can determine if you set up your rules correctly. All right, for the next one, using the same graphs, where are they increasing, decreasing, and constant? So your intervals are always your domains. They're your x values. The easiest way, I guess I can explain it without having a pen or pencil, is to use a ruler. And, well, actually, I'm going to do that for domain and range. That's better. For increasing and decreasing, you can just really use your finger. Here, I'm neither increasing or decreasing. It's constant. But where is it constant? Again, this is my domain information. It's going to be constant between the intervals of -8 and -3. And notice I do not use brackets for increasing, decreasing, or constant for my intervals. It's just going to be open the parentheses. If I go to my next graph, take my finger and trace it, what am I doing? I'm decreasing. But where am I decreasing from on my x values? From -1 to +1. So that's decreasing, -1 to +1. Then if I continue on, I am now, if I'm tracing with my finger, I'm increasing. Where am I increasing from on my x axis? I'm increasing from 1 to 2. So that's what we're going to write here. Increasing 1 to 2. And now let's go to our last graph. What am I doing x-wise for this graph? I am going down, I'm decreasing from 3, and then I can go on forever and ever and ever. So 3 to -infinity. So since I already have something for decreasing, I want to put a union sign there. And union 3 to +infinity. So that's where I'm going. And if you look up here, it already told you that, really. So you see the first one, it mirrors that. The second one mirrors that. Well, without the -1 part. Let's make sure we did that right. Yeah, here's the -1. Okay, and then we also have the numbers. We have the 3 as well. So it's all shown in our conditions. Let's move on to this next one. This is the last one. So I'm determining domain and range, which we literally just did for the domain, basically. We're going to actually go left to right again. This is where I was saying if I had a pencil or pen, it will be easier to demonstrate. When you're reading for domain, again, you're looking for your x values. How many of these x values can fit on my graph? So what I'm going to do is demonstrate using this ruler. So my first point that I start with my very first graph is at -8. But I look at my circle and it's open. So I know that I can't include it. -8. And I can keep going on my x-axis until I get to -3. And again, -3 has an open circle, so I would not use brackets. Now, domain and range, you do use brackets if it's included. If I keep going over, I start again at -2. When I do something again, that means I'm going to have a union. And -2 is a closed circle, so that means it's included. And I go from -2 and I keep going and going and going and going until I get to 1. Well, 1 is an open circle, so that means I use a parentheses. I can't include it. If I keep going, I'm skipping 2. I start again at 3. So I have a union. The 3 has an open circle, so I'm using a parentheses. And now my arrow on my graph tells me I can go on and on and on forever. Going on forever to the right means positive infinity. Okay, so the same for the range. For my range, I'm going from bottom to top. That's how you read your graph. So let me turn this ruler this way. Bottom is going to always start from negative infinity. Well, negative infinity is not included, of course. So negative infinity, I keep going, 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 going until I get to -7. -7 has an open circle, so I'm going to use a parentheses. Union, keep going. I start again at 0. 0 is actually included on my y, in my y values. And I can keep going up to 4. 4 is also included, so I'm going to have a bracket there, a union sign, keep going, and this one is kind of tricky for some people. So what this means is 7 is actually included, even though you see those circles, 7 is included towards it, and it's going to be 7, 7. And you may wonder why. The open circles represent your x values. If I am talking about my graph actually crossing, it will cross over the 7 on my y-axis. So it is included. We're not looking at the x's. So that's why that is showing as holes in the graph. But it actually isn't included in my range. So I hope that helps someone. I would like for you to please go ahead and like, subscribe, and let me get back to these calculator steps for you and freeze it so that you can copy it. Have an awesome day.